Dear students, welcome to mathematics online classes. In the last class, we did up to property P6. Now, property P7 we are going to derive. Property P6, P7 most important properties, and also if this property is asked, it will be asked like 5 plus 1. Marks distribution will be 5 plus 1. 5 will be for the property derivations and 1 mark will be for the problem which is given on the property. That is why. Okay, property P7. First of all, we will see what it is saying. If there is a integral of f of x from minus a to a, minus a to a means it can be from minus 1 to plus 1 or minus 2 to plus 2, minus 3 to plus 3, like that. Anything, this is equal to, we should take it as 2 times integral from 0 to a f of x into dx if f of x is even, and this is equal to 0 if f of x is odd. Here I will tell you what is an even function and what is an odd function. First of all, suppose we have the function sin x, f of x is equal to, if I have sin x, now what I do, I will change x by minus x. What happens? This is f of minus x is equal to sin of minus x. I am changing x by minus x. Then what is sin of minus x? It is nothing but minus sin x. Minus of sin x is what? Sin x is f of x. You see, we are getting f of minus x is equal to minus f of x. In the same way, let me consider the function f of x is equal to cos x. This is f of minus x is equal to, means changing x by minus x, we have f of minus x is equal to cos of minus x. We all know that cos of minus theta is plus cos theta, like that. So, cos of minus x is a plus cos x. This is what? This is f of x again. F of minus x is equal to what I am getting here? I am getting plus f of x, here I am getting minus f of x. If we get f of minus x is equal to plus f of x, then we call such type of functions as even functions. And if we get f of minus x is equal to minus f of x, we call such type of functions as odd functions. Now, in case of trigonometric functions, cos and secant are even functions. Other 4 trigonometric functions, sine, cosecant, cot and tan are odd functions. So, that is what. Here they are saying that integration of f of x from minus a to plus a is equal to 2 times 0 to a f of x into dx if f of minus x is equal to plus f of x, means function is a even function. If it is odd function, means f of minus x is equal to minus f of x, then directly its integral value is a 0. They are saying this. This is what the property P7 is. Now, coming to its derivation. Not only the trigonometric functions, even we can consider algebraic functions also. See, let me take one more example to explain odd function and even function. Suppose I have f of x is equal to x square. What happens here? F of minus x is equal to minus x whole square. This become plus x square, means plus f of x. So, x square is even function. Now, if I consider f of x is equal to x cube, what happens? F of minus x is equal to minus x whole cube. Minus minus minus, how many times? 3 times it is multiplying. This is minus x cube. Minus of x cube is f of x. See what I am getting? F of minus x is equal to, I am getting minus f of x, means x cube is which type of function? It is odd function. Yes, this is what even function and odd functions is. Already you know it. Now, we will go to the derivations. So, let me take integration of f of x with respect to x from minus a to plus a. From minus a to plus a, instead of integrating from minus a to plus a, I will integrate from minus a to 0 first, f of x into dx plus next 0 to a f of x into dx. Let me name this as equation 1. How I am doing this? Because using the property integrating from a to b f of x into dx is equal to integrating from a to c f of x into dx plus integrating from c to b f of x into dx. This property I am using here. Okay, fine. Now you see in the right hand side we want 0 to a. This function means this integral, you don't do anything, don't do any kind of modifications with this, let it be as it is. Now coming to this integral, minus a to 0 we don't want here, minus a to 0 we don't want. So what you do, take this as I. Now I is equal to minus a to 0 f of x into dx. In this we will keep on doing modifications. What is that modification we will do? As we did in the P6 property, there we wanted t is equal to 2a minus x. In the same way, here what I want f of minus x to consider case 1 and case 2. In place of x we want minus x, So what you substitute? In place of x you substitute minus t, or t is equal to minus x. This implies x is equal to minus t. Anything you can substitute. With that we will get f of minus x, so that we can consider the cases. Okay. Now differentiating the function t is equal to minus x with respect to x, we have dt by dx is equal to differentiation of minus x is minus 1. Here only dx is there, we can write here minus dt is equal to dx. Minus dt is equal to dx we got. Now upper limits and lower limits we need to change for the new variable t. That is, when x is equal to minus a, what is t equal to? Here you see one minus is there, x value is minus a, minus minus becomes plus, this is plus a. Next, when x is equal to 0, that is upper limit, what happens to the t value? Minus into 0 means that one is also 0 only. Okay. Now here I will write what happens to the I1 value. I1 is equal to integration of f of, in place of x, what is there? X means minus t here, f of minus t into dx is nothing but minus dt, minus I will write outside into dt. Now what happens to the upper limit and lower limit? Minus a become plus a, 0 is 0 only again. Now we have I1 is equal to, if I interchange upper limit and lower limit, what happens? Integral sign changes, minus become plus. This is f of minus t into dt. You write here because integration of f of x from a to b with respect to x is equal to minus of integration of f of x with respect to x from b to a. We know this. Okay. Now I1 is equal to, sorry, it is not I1. Here I took it as I. Let us write I only. Now what happens? 0 to a f of, I don't want this t, I will change the variable t to x, f of minus x into dx. How is this? Because using the P0 property, integrating from a to b f of x into dx is equal to integrating from a to b f of t into dt. Just changing the variable, we did this. Okay. Now what I do? I will substitute this I in the equation 1. Now equation 1 implies integrating from minus a to a f of x into dx is equal to minus a to 0 f of x into dx is the I. In place of that I will substitute here, this is 0 to a f of minus x into dx plus of second integral is 0 to a f of x into dx. This is what? This is I will name this as equation 2. Now equation 2 we can consider with the cases. Yes, now equation 2 I will consider in both the cases. That is, first case when f of x is even, that is f of minus x is equal to plus f of x. You have to be careful here. In question papers they may not mention both the things. That is, if f of x is even means f of minus x is equal to plus f of x, they may not mention it. Simply they may say f of x is even and f of x is odd, or they may say it as f of minus x is plus f of x and f of minus x is minus f of x. Any one they may mention or both they may mention. You have to be clear enough with the concept, what is even, what is odd. Okay. Now when f of x is even, that means f of minus x is equal to plus f of x. What happens to the integral from minus a to plus a? I will take with the equation 2. Equation 2 implies integrating from minus a to a f of x into dx is equal to integrating from 0 to a f of minus x is equal to, what is there here? F of minus x is equal to plus f of x here. Yes, this is f of x into dx plus, again it is integrating from 0 to a f of x into dx. Second integral I am writing as it is. See, 0 to a f of x into dx, 0 to a f of x into dx. This is nothing but 2 times 0 to a f of x into dx. Yes, we have proved. Now case number second, that is when f of x is odd function. When f of x is odd, that is f of minus x is equal to minus f of x, then what happens to our integral minus a to plus a? Integrating from means I am substituting in equation 2 there, minus a to a f of x into dx is equal to integrating from 0 to a f of minus x is nothing but a minus f of x. So that minus I will write outside, minus of integrating from 0 to a f of x into dx plus 0 to a f of x into dx. See, same integral here multiplied with minus, here multiplied with a plus, both get cancels, that is 0. See, we got the answer. This is how we have to prove property page 7. Now we will move on to the examples. Examples on properties of definite integrals. Example 30 I am going to take. Example 30 is example 30, it is given evaluate integration of modulus of x cube minus x with respect to x from minus 1 to 2. Here integration of a modulus function is there. Integration of a modulus function we can't do it directly, we need to take it into algebraic based on the conditions of that modulus functions. See, first of all I will explain what is an modulus function. We all know modulus of x is equal to plus f of x when x is greater than or equal to 0. It is minus x when x is less than 0. We all know it. Now in the same way, suppose integral is given from -1 to 2 modulus of x into dx, then how we integrate it? We will integrate by splitting it into 2 or more integrals. See, it is -1 to 2. On a number line, if you do, it is -1, here 1, here 2 is there, 0. From 0 to right hand side, function is different, that is plus x. From 0 to left hand side, function is different here, that is minus x. So what we do, instead of integrating from -1 to 2 directly, we will split it into two integrals, -1 to 0. -1 to 0 modulus of x into dx plus of next part 0 to 2 modulus of x into dx, we will split. Now it is -1 to 0. What is that modulus of x? Minus x or plus x? Yes, -1 to 0, we need to take minus x into dx. Next 0 to 2, it is plus x according to the condition, plus x into dx. Like this we will split this integral, modulus integral, then we will take integral, means then we will integrate it. In the same way, how will you take with the integral here? Here the given function is, you see, modulus of x cube minus x it is, modulus of x cube minus x. Modulus of x cube minus x is equal to plus of x cube minus x if x cube minus x is greater than or equal to 0, according to the what? According to the modulus function definition. And now it is minus of x cube minus x if x cube minus x is less than 0. Now in this case, to take plus x cube minus x or minus x cube minus x, do we know my x cube minus x is greater than or equal to 0 or less than 0? We don't know. To analyze that, x cube minus x is greater than or equal to 0 or less than 0, I will draw the graph of x cube and x. See, let us draw the graph of y is equal to x cube and y is equal to x on a single plane. Here y axis, this is x axis. I want only in the integral, I want only in the range -1 to 2. Okay, -1 to 2 means somewhere here -1, this is 0, this is +1, here it is +2. Now you see, I am drawing the graph of y is equal to x. When x is equal to 0, that is 0. When x is equal to 1, that is y is 1, means if I take here 1, here 2, like this it goes, here -1, -2. When x is equal to 0, y is equal to 0, point 0, 0. When x is equal to 1, y equal to 1. When x is equal to 2, y equal to 2. X is equal to -1, y equal to -1. Now means y is equal to x is a single straight line. Okay. Now how is the y is equal to x cube? Y is equal to x cube. You take x is equal to 0, y is also equal to 0, means this is the point. Next, when x is equal to 1, y is also equal to 1. 1 cube is 1. Here is the point. When x is equal to 2, y is equal to 2 cube, it is 8. So point is 2, 8. Somewhere here it is 2, 8. When x is equal to 3, y is equal to 9. 3, 9. Somewhere here it comes. Okay. Yes. Now in the same way, when x is equal to -1, y is also equal to -1. When x is equal to -2, y is -8. Somewhere here it goes like this. When x is equal to -2, y is equal to -8, means somewhere here it goes. So this is what it follows. And also we can consider some points also here. When x is equal to 0.1, is it 0.1? No, it is 0.1 to the power of 3. 0.1 into 0.1 into 0.1, 0.001. So here it is. You can consider x is equal to 0.5 also. X is equal to 0.5, then what happens to the y is equal to 0.5 to the power of 3. 0.5 to the power of 3 is 5 into 5 into 5. This is 125. 3 decimal points are there. 0.125. When x is equal to 0.5, y value 0.125. Somewhere here it comes. Means graph of y is equal to x cube, it is taking the form like this. Graph of y is equal to x cube, it is taking the form. Here 8 is there, 8 to 1 and next 0 and then minus 1, it is taking the form like this. This is what y is equal to x cube is. See, point is here it is not included in the y is equal to x cube, this is included only in the y is equal to x. 2, 8 will be somewhere here. So, when x is equal to 1, y is equal to 1, this point is coinciding, this point is coinciding, this point is also coinciding. This is how the graph of y is equal to x cube. Okay, you see, while integrating from minus 1 to 2, while integrating from minus 1 to 2, modulus of x cube minus x into dx is equal to minus 1 to 0, I will take 0 to 1, I will take next 1 to 2, I will take, because 0 to 1, this x cube values are greater than the x values, and here 0 to 1 again it is changing, x values are greater than the x cube values, 1 to 2 again it is changing, x cube values are greater than the, I can take in the single stretch here. I am dividing it into 3 parts. Minus 1 to 0 I will take first. Minus 1 to 0 modulus of x cube minus x into dx plus 0 to 1 modulus of x cube minus x into dx. Next 1 to 2 modulus of x cube minus x into dx I will take. Okay, fine. Integrating from minus 1 to 0. Minus 1 to 0, x cube values are greater here. This is x cube curve and this is x curve. X cube values are greater. What happens to the x cube minus x? X cube minus x will be positive, you know. So, we will consider this is x cube minus x plus x cube minus x into dx we will consider. Next, integrating from 0 to 1. Integrating from 0 to 1, which one has the bigger value? X has the bigger value, x cube has smaller values, means x cube minus x will be what? Here x cube minus x will be negative, x cube minus x will be less than 0. When x cube minus x is less than 0, according to the definition of modulus function, what I have to take? I have to take this as minus of x cube minus x into dx. Next, 1 to 2, if I consider in this interval, which one is bigger? X cube is bigger. Then what happens to the x cube minus x value? X cube minus x will be positive. So, I have to consider plus of x cube minus x into dx only. This graph is just for explaining how it comes and how to split the integral here. Yes, I will erase this. Now, integration of x cube minus x into dx from minus 1 to 0. Minus will get multiplied with this. This is integration of minus x cube plus x can be written as x minus x cube into dx from 0 to 1 plus of integrating from 1 to 2 x cube minus x into dx. Now, we can integrate it very easily. What is integration of x raised to 3? It is x raised to 4 by 4 minus of x square by 2 from minus 1 to 0. Again it is x square minus 2 minus x raised to 4 by 4 from 0 to 1 plus of x raised to 4 by 4 minus x square by 2 from 1 to 2. Okay. Now, we will substitute the values. Substituting upper limit x at 0 raised to 4 means it is 0 minus 0 minus of substituting the lower limit minus 1 raised to 4 minus 1 raised to 4, it is even number, so answer is 1 by 4. Minus of minus 1 square will be plus 1, plus 1 by 2, plus of, here substituting upper limit 1, that is 1 by 2 minus 1 by 4, minus of substituting the lower limit 0 minus 0, plus of, now substituting the upper limit here 2 raised to 4, 2 into 2 into 2 into 2, 4 times, that is 16 by 4, minus of 2 square by 4, 2 square by 2 means 4 by 2, minus of substituting the lower limit 1 by 4 minus 1 by 2. It is 0 only, leave it. Minus will get multiplied with this, minus 1 by 4 plus 1 by 2, plus of 1 by 2 minus 1 by 4, this is minus, leave it. 4 1s are 4 4s are 4, minus of 2 1s are 2 2s are 2, minus will get multiplied, minus 1 by 4 minus minus plus 1 by 2. Okay, I have here, you see, minus 1 by 4, minus 1 by 4, minus 1 by 4, 3 times, we will write here minus 3 by 4, 1 by 2, 1 by 2, 1 by 2, that is 3 by 3 times 3 by 2, 4 minus 2 is 2. LCM is 4 here, this become minus 3, 2 into 3, 6, here 1 is there, 4 into 2, 8. Minus 3 plus 6 is 3, 3 plus 8, 11. Answer is 11 by 4. Okay. This is about example 30. In the next class, we will take some more examples on the properties of definite integrals. Thank you.